Bonjour à toutes et à tous. Donc là, on commence la dernière journée de conférence. Et les conférences de ce matin seront tenues par Maria Ferrara et Elena Guidetti. Donc on commence avec Maria, que vous connaissez, qui vient du Polytechnique de Turin et qui nous présente une petite présentation Cities Toward Carbon Neutrality, Digital Twins and Design Approach for Decarbonizing the Urban Built Environment. Thank you, Maria.
Thank you, Emma, and good morning, everyone. So Elena and I, we are presenting some activities on basically at the city scales and some multi-scale studies, but the basis is the city scale that we conducted on our joint lab, interdisciplinary lab, that is the Future Urban Legacy Lab. You will learn some details about this lab while we present our activity. So I'm starting with some research and activity more related to policy making, we can say. So the target, everybody is talking about decarbonization, urban decarbonization. Even in our atelier in these days, we are talking a lot about sustainability and decarbonization. And at the worldwide level and European level especially, decarbonization is tackled at city scale. So there are several initiatives that are targeting cities, because city is like a mesoscale between like a nation and one building, okay? It's a very complex environment where the built environment, buildings, of course, occupy a crucial role in carbon emissions and also in decarbonization scenarios. But then, within the city environment, it is possible to see all the interdisciplinarity that is related to decarbonization. Because we have buildings, but then we have buildings in a city with streets where mobility is used and where green areas are there, when water is used, not only energy, and so on. So there are several sectors that are intersecting within the city environment. And so there are these initiatives of the International Energy Agency, this technology collaboration program that are putting together networks of cities that are working together to understand which are the best policies to decarbonize. And in particular, what we're working on in our lab is this EU mission, Climate Neutral and Smart Cities, that is considering 100 of pilot cities throughout the entire Europe. We'll see here are all the participating cities in this mission, and we are trying to consider scenarios for reaching carbon neutralities, considering all the sectors we were mentioning. So the stationary energy, where buildings are there, of course, it's one of the most emitting sectors, but then we have transport, waste, industrial processes and product, and agriculture, green areas, and so on. So we are taking this challenge of decarbonization from a very multidisciplinary approach. Considering emissions throughout the entire life cycle, but also considering the path, the location in which these emissions are produced, because we consider a city as a boundary, but there are some emissions that are produced outside the city boundary, but they are produced because they are like needed. There are services related to these emissions that are needed within the city. So we have direct consumption within the city boundary, but also we should consider indirect consumption that are outside the city boundaries as a result of activities within the boundary of the city. So this is just to give you the idea of how complex it is to design decarbonization scenarios for a city. And since we are placed in Turin, we are working a lot on the city of Turin. The city of Turin is one of the cities in Europe that is involved in this mission. It's like one of the leaders, we can say, because it's together with other pilot cities, we are trying to make a joint group working not only on the practical decarbonization implementation of actions, but also in developing a new theoretical, we can say, and strategy. So we're working more at research level with other cities to understand how also science theory can be affected by this practical example of city decarbonization. And so this is done basically for policy making. We're saying that policies are very important in this period to foster decarbonization. Policies are enabling decarbonization, because when we want to approach a very complex system, we don't have to look at private initiatives. Okay, we have private initiatives, of course, they are essential, but private initiatives can be done only if there is an enable environment, like policies that push privates to carry out initiatives for decarbonization. And so what are the main questions that become research questions in our activities? First, it's related to data. Data are crucial. How to gather and manage reliable and usable data on the current situation. And then once we have a data, we have a mapping of emissions throughout the city, and for the building sector specifically, how emissions are produced from the different buildings, which building retrofit intervention and where are the most impactful for the entire decarbonization of the city. And so then we need to engage the community. So third research question is how to monitor and visualize the impact of action. Because emissions is something that everybody's talking about, but we cannot see them, okay, as a direct. So we should find ways to engage the community and to make them aware of the impacts of their actions, both positive or negative, on the decarbonization path. Okay, so I'll try to provide you some of course, we don't have the time to go deep into the several projects, but I will provide you some images. Okay, so we have already talked about this. We are considering scale, the building stock scale, because, okay, going from the city, we are working specifically of the built environment, we said. So we're working on the building stock. But then, with a cross-scalar approach, we also keep moving from the building stock to the individual building and back, because they are very related. Each building is important because it contributes to the decarbonization of entire building stock, but then the entire building stock should go towards decarbonization in order to make each individual building be decarbonized. So it's a very bionivocal relationship. So first question, where to renovate and how to renovate. Renovation leads to decarbonization of building stock, okay? Our pilot project is related to an interdisciplinary approach in between architecture, energy science, and also earth observation and geomatics science. We have acquired a great amount of high quality data. From where? Because the first question, you remember, was related to data. So from where we have taken this data? We have taken this data from a plane, where flight over Turin, and okay, these are some details, not so very interesting, but thanks to this, we have obtained, okay, we have obtained a photogrammetric model, very, very detailed, with a resolution of 5 centimeters of the city, of the entire city. There are just some pictures. this is not real picture. These are not real pictures, but this is our model, okay? Very, very detailed of some part of the city of Turin. This is our School of Architecture in Valentino Castle. And you see, this model comes from LiDAR acquisition with point clouds associated to several pictures, hyperspectral, in order to have the highest possible resolution. And so we have our digital twin, because it's not just a representation, realistic, photorealistic representation of what's there. But if you click on this model, on each roof, on each wall, on each building, you visualize data for that. So materials, emissions associated, energy consumption that produced emissions, how the building is used, what's the building typology, when the building was built, and so on. So it's a model, photorealistic, but you can explore it, explore its metadata with a very high level of details. We also acquired thermal pictures. So within the same flights, we also got thermal images. And these thermal images were useful to be able to perform an energy mapping of the city. So, okay, I'm sorry this is not very good as an image. I see it much better here, but okay. This is a 3D model in terms of thermal, so it's a thermal 3D model that helped us building energy models because with thermal pictures we can visualize thermal losses occurring within the buildings and understand which are the best buildings, which are the worst buildings, how buildings are losing energy. In our atelier, we're talking about thermal losses, okay? With these pictures, we can quantify thermal losses for all the buildings in the city, so it's quite straightforward. And so based on this, we were talking about the importance of data, and thanks also to the use of AI-based algorithm, we were able to perform an extended energy mapping of our buildings. So now we have a digital twin where we know exactly which is the energy performance of all buildings and which are the materials that are implied in this energy performance of the building, so that we can visualize the impact of future scenarios. And automatically we were able to segment our building stock, so we could classify our buildings according to their typology, their construction period, and so on. And this was performed automatically, extensively on the entire city. 60,000 buildings, maybe more, in Turin, they were all classified by this. So we can perform decarbonization scenarios at very large scale. And first, we were saying about energy mapping. You know that Europe is asking us to classify buildings in terms of energy performance, so to assign an energy performance certificate to each building that nowadays is very time-consuming because you need an expert that goes into the building and take notes of how the building is made, materials, and so on, and perform calculation and produce this energy performance certificate. Thanks to our algorithms and model and data gathering, we were able to automatically classify, so to assign an energy performance certificate to all buildings in the city with a significant saving of time saving, we can say. So we were able to classify 100% of the building stock with a quite good accuracy, considering that we are just looking at buildings from above, okay, without entering the building. So it's also a non-invasive approach that helps you, even in some critical contexts, some like historical buildings, for example, protected buildings, where you cannot go inside, make invasive analysis. Just looking at them from above, we are able to extract a lot of useful information. And so this is just to show you the different layers of our model. These are layers of part of our city, okay? So we had the thermal picture segmented. We have same buildings classified in terms of energy performance certificate. Best one is A, worst one is G. You can see it's basically everything is red, so worst performance. And of course, related estimation of energy consumption for each building. So at the same time, we're able to calculate the entire energy consumption of a city, but then to go very in detail to each building and to know exactly how much energy the building is consuming. And not only related to consumption, but also, if it's not going, I don't know. Okay, it's going. But also visualizing the potential for renewable energy production. So this is our model again. And this is the layer of photovoltaic potential production. So you can see it's very, very detailed. We're not just calculating approximately, which is the photovoltaic potential for a roof oriented south and with a 40-degree slope. We're considering exactly every particular of the roof so that it's possible to make an executive design of a PV panel, for example, installation of this roof. So we can exactly understand which is the photovoltaic potential of each roof in the city. And so with very detailed mapping of energy demand on one side, of energy production on the other side, make a city scale and a single building scale, we were able to provide scenarios for renewable energy communities in urban context. Okay, the renewable energy communities are those communities that can produce the energy they need, okay? But they should be sized properly. We should understand how much energy is needed and how much energy can be produced within the community. And thanks to this digital twin, we were able to do it extensively for the city of Turin and also beyond for other areas in the surroundings. And this is what we were talking about engagement. So this was because there are some layers that are like hidden to the citizens we are using as a scientist to extract information and to perform analysis, algorithm scenarios, and so on. But we also have a public platform that is made jointly with the city municipality, where citizens can navigate and they can perform analysis on their own building. They can say, okay, this is my house, let's see which are the characteristics of my buildings, and so on. And this is quite interesting because we are trying to engage also the citizens in taking climate actions, and this is essential. Because on one side we have policies, on the other side we have engagement so that all the community can make climate action. And this is a very useful tool we are experimenting. Okay, this is just some, of course we have performed some decarbonization scenarios for the future. And for example, for the sector of the built environment, the building and energy system environment, we potentially are able to cut by 66% CO2 emission of the entire city. So we understand the importance of buildings within a city, and on the other side, the importance of this tool in order to be able to correctly estimate this potential emission reduction. Last concept is interdisciplinarity. I've started talking about that, I finished talking about that, because we know that when we take actions, okay, this is just a theoretical scheme of the ontology of the city. I don't have time to go in deep, but just to understand that when we take action, these actions, for example, renovate a building, has an impact not only on that building, on the built environment, but it has impacts on many interrelated systems, on the market, on the infrastructure, on the technology, on the social behavior. And so we are trying to conceptualize this ontology mapping to map the cross-sectorial interactions between the different systems that are affected when we take some actions like building renovation. And this is something that is under development, but this is just to let you know that we have 3 pillars if we want to talk about decarbonization of cities. Data, and we are trying to advance this data gathering through Earth observation, and so to get multi-physics, multi-domain, spatial and temporal observation, so that we can even assess the value of variations of the data throughout time. Then we have models. It is essential to be able to build and to manage such complex models that allows you to go from the city scale to the building and back. And interdisciplinarity. Interdisciplinarity is essential. And our lab, which is the Future Urban Legacy Lab, is a place for multi-scale interdisciplinary project. And so I let the floor to Elena to keep telling you our project in our lab.
Thank you so much.
No, perché non si è scaricata la presentazione.
We are coming. Bene, vediamo da qua.
Faccio da qua.
Sì.
Volete la chiave?
Ma no, ma seems it's working or about to. Proviamo, prova a attaccare.
Ma tanto non si va, la presentazione non va. No, forse va.
Ok. Okay, let's see if it's working. Okay, nice. Hopefully it will stay all the next 20 minutes. If not, I will just keep talking. Okay, good morning, everyone. I will follow up the intervention, the presentation by Maria Ferrara, by adding some more details about some selected research project that we are carrying out in our research lab. First of all, I have no idea if you know what is a research center, more or less, in university, but probably, I mean, I was totally not aware of the existence of such a place before my master. So research center is actually a place where people could be inside the university. Let's make this example, that people that have different expertise stay together to elaborate solutions to shared problems. So you could be an architect and be working in a research center, and your output is not a project, a proper project site-specific, but our visions, our reports, our analysis or project that can support site-specific developments, okay? I don't know if it was clear. If it's not, you can ask me later. Full, that stay for the Future Urban Legacy Lab, is a research center based in Politecnico di Torino. It's gathering together 54 fellows. Fellows mean professor, postdoc researcher, PhDs, master student too. And 7 departments, means that I'm part of architecture and design, because I'm an architect, but Maria, for instance, is part of the ENERG, so the energy departments. and we are working together on selected researchers. Today, I will show you 2 macro groups of researchers that are the one that I'm involved to, so I can talk properly about it. The first one is related to Atlas of Potential, and the second one is future heritage landscapes. All those research are all those research are focusing on adaptive reuse of the built legacy. If you want to look up the research center, of course, we have a website, so you can navigate it. And the 3 pillars where we stand are all 3 related with transitions. So ecological transition, just transition, but in this case it's physical transition in terms of buildings, policies, and buildings physical stage, and digital transition. Okay, so the project that I will report today are related to adaptive reuse. So any process of reusing obsolete or derelict buildings, and not just buildings, we will see also landscapes and part of the city, by changing its function and maximizing the reuse and preservation of existing material. Of course, looking at the future of users, so what you tomorrow would like to be and to stay in. And the ground is the urban legacy. Maybe you're not familiar with the term urban legacy. Just think about a broader concept than heritage. So it's everything that you inherited from the past. And sometimes it's good, sometimes it's not. For instance, we all agree about some kind of buildings or landscape that for us are a shared legacy. So it's something that we want to preserve, we want to, I mean, they're beautiful, okay? We like them. We are proud of them. And some other parts, and that's most of our cities actually, are just part that we got from the past and we don't know how to deal with them. For instance, think about the factories, dismissed factories or polluted lands, but we have to deal with them. So in those projects, we are trying to do it in different ways. The first family of projects that I will just report the first one, that is based on my PhD research that I finished 3 years ago. And it's about assessing the transformative potential in existing buildings. In particular, by studying the morphological aspects of the transformation and embodied energy. Of course, for instance, our design studio, or I don't know, part of the workshop, is rooted in one of the subfields that are coming from this research. So we are calculating embodied energy and embodied carbon in the process of adaptive reuse, office to residential in this case. Okay, so we have been talking a lot about interdisciplinarity, etc., but what it means that I'm more or less in the parts in the center. So I'm enjoying some methodologies and some way of looking at the reality that are proper from building morphology, so something that is more close to your studies probably as architects, and some other theories that are connected with the stage of decay of the building, and a part that is related on life cycle analysis, that is, we have been talking a lot in these days, everyone have been talking about, is the whole process of the building in terms of energy, from the construction to all those phases, operational, and then dismission again. I can skip this one. Okay, I know that seems not making sense, but it does. So the first shifting in collecting this atlas of potentials, so in analyzing those buildings, was to move from one perspective, that is classifying what we see in terms of what we know about them already. So if you see, I make an example, a bottle, you see that's a bottle. But that's actually a box that contains liquids, is transparent. So instead of looking at what we define as we already know, look at them in terms of what they can do. So, and that's particularly interesting in case of buildings and urban legacy. So we don't know how to deal with them. So let's not consider them as factories or as dismissed something, but consider them as with some physical properties, with some materials, so based on what they can do, what they are capable of. And what I did was to select among 16 more or less case studies, 70 case studies, 16 buildings in the end. They were buildings or part of buildings or part of infrastructure too that have been adapted in the last 15 years in Europe. Okay. I hope that is not make you dizzy, okay? But, what I did is to perform several analyses, multiscalar, in terms of morphology, in terms of circulation, in terms of access, in terms of configuration, and also to have comparable data in the end. So both in terms of space and in terms of amount of materials. That means embodied energy also. So in the end, I will just tell you about the embodied energy part because the other one is really boring and super long. Those are, for instance, the material quantity associated to each building. The red part is the part about the intervention, the new intervention, the adaptive reuse. Everything that is black is existing, and even if it's not really correct for the engineers, in negative, we see the part that has been demolished. What we see in the end is that we have actually a huge amount of existing materials that most of them are even more than new projects, even really transformative projects. In the end, with other parameters, if someone is curious, we can talk later, I classify 4 families of transformative potential based on what they can do in terms of morphology, in terms of embodied energy amount in each one of those transformations. What's important is that, of course, we cannot draw something about the 16 case studies. So I start build is still ongoing, an atlas. You can find it online, but it will be better in 6 months. So trust me, we are working on it to actually map a lot of intervention, even relevant, not relevant, doesn't matter. But relevant cases, so a family that is case studies, example and unexpected cases all around Europe. And in doing so, dividing them in terms of amount of material, and kind of intervention. This could be functional, both to have, of course, a repository about everything, that's nice, but also about finding some patterns in transformation that can teach us something. So in the end, what's coming out from that research that I do think that could be interesting to share with you is, of course, that you will be designed on existing buildings. It's a matter of fact, if you want to work in Europe, for sure, most of your work will rely on something that someone else built before you, and that's okay, it's fine. But then when you look at that kind of buildings, try to look with multiple lenses basing your thought, your design, your project, looking at what is physically there. So how large it is, how tall it is, which kind of material, which kind of configuration which kind of rhythm your building has. It's banal, but I just want to repeat it. And then, of course, in the end, if you are evaluating what is already there, that is something that normally engineer doesn't do, because it's already spent, that energy, so we cannot do anything about it, but we can be conscious. So if I say that a huge building that I don't like is storing a lot of energy that someone else spent 100 years ago, that's matter in terms of preservation, in terms of transformation. It's a powerful argument. And if you support your thoughts with powerful argument, people listen to you. If you don't, even if they are not agreeing, in the end, they have to listen to you. All those parts, you can even find it on this book that is on the way to be printed. So in May, for sure, you can find it. And then in 5 minutes, I will just show you 3 other research that we did in the last years that are looking at the heritage landscape and this urban legacy with multiple lenses. So we are applying adaptive reuse to landscape and to part of the cities. In this case, as a research center, normally you get commission from people. Sometimes you have curiosity-driven research, so you are supported by the university to do it, of course, because you are part of the university, but you can also engage research with municipalities, private and regions, European Union, institution. In this case, the region, the Piedmont region in Italy, ask us to do comparative studies between these 3 heritage buildings with the minimum intervention possible, make them functioning again. So we did 3 projects using as less as possible in terms of modification, so materials, space, and money, of course. And to do it, of course, the team was interdisciplinary, so we have someone that was taking care about the money part, another one that was taking care about the landscape, so a landscape architect, and a guy from the economics, 2 people from the drawing part that were flying drones to have precise data, and the designer parts. Another project that we are that we closed last year, actually, is wrong, it's 2024, but doesn't matter, was by the municipality of Turin. And we are quite proud of it because they have been including some part of the report that we made for them to design the urban policies for the city. So it's also nice. You know that your thoughts are having an impact somewhere. In this case, the project was to find out a system to connect different dismissed or not so well used spots in Turin. In particular, not just spots, but along the river. This is the Po River, is the main river in the north of Italy, and Turin is crossing Turin, actually. This part, number 5, this is where Faculty of Architecture is, and is along this park that is called Parco del Valentino. And we did those focus projects. And in parallel, to bring a macro scale perspective, we also identify on all the axes of the river parts that were carrying a lot of potentials in terms of renewal, in terms of intensity of functions. So all the yellow parts is actually what we are saying to the city, please invest on it, because if you do this system, it's going to be powerful, the design in the end. As you can see, I mean, we did some, of course, simulation, pilot projects, but the approach is those numbers means that we are actually providing a toolkit, not doing a project site-specific. So we are saying each number means a kind of intervention. You can draw it and design it in 1,000 different ways. But the point is, if we want to repave the and remove asphalt and to put like a soil that make your well-being better when you are walking, that's the kind of intervention, is the number 14, and you can use a lot of material to do it, a lot of design to do it, but I'm not doing your job, I'm just saying you should do that, okay? So it's a toolkit to provide solution, potentially solution from for designers, and in this case to allow the city to make a policy about it. We also did a bridge, 31. They will never done, but doesn't matter. This is the Faculty of Architecture, by the way, the castle. Okay, last one. This is a project that is still ongoing, so I will show you something, but it's on the process. As I told you, sometimes in our research center is also private people from the companies that can ask you to do a research. In this case, this group that is a society, a company that is doing photovoltaic fields. So not always the good guys in terms of landscapes. And is also producing olive oil. So they bought this property, really huge one, here, where the marker is, and that is in Puglia region, in the south of Italy. It's a really beautiful place. And this is the shape also, this arrow is nice. They asked us to do a study to doing an adaptive reuse of this ancient village that was made in fascist time, let's say. It's a really beautiful place, but is dismissed since 30 years, more or less. But not just about the building, but also about the place, because this is a building. I mean, it's nice. But look around, you see a lot of olive trees. Okay, that's the actual condition right now. But I don't know if you are aware, but we had this kind of pandemic related to this Xylella that was destroying the 90% of olive trees in the south of Italy. So was not just an adaptive reuse of the village, but also about the territory. So we do propose an integration between agriculture, a new kind of agriculture, and a new kind of energy production, along with the renovation of the adaptive reuse of the village. We have been doing the same thing that we did with the buildings. We were studying the story of these fields, its structure, its configuration, and what it was in terms of agriculture along the history. And the last one is, all the black is the Xylella pandemic. And in the end, we propose a co-productive landscape that is also, there are a lot of also photovoltaic panels, but they are actually agrivoltaic, so integrated with the agriculture. And of course, we did a kind of draft project. And to do this, you cannot do it alone. I mean, I had no idea which kind of measure between one tree and another, or I don't know, which kind of machine to take olive out of a plant. So we did a really huge team to do it. I was in charge of the design part, but we were like 20 people involved. So you should take in account that you will never work alone if you want to work on these kind of things, and thanks God, because I finished. Just reminder, I do think that what could be interesting for you to catch is to remember to embrace quantitative approaches. That means that if you are proposing a project and you are saying that it is sustainable, if you support it with data, it's better. Even the ones that are not agreeing with you cannot speak against you at some point. So, for instance, making some calculation, I'm really bad in calculation normally. But once you get to know how it's working, you can really use those data, for instance, the one about embodied carbon, embodied energy, or whatever, to support your design as a designer. And of course, you have to talk with other people that are not having your background, because otherwise you're not going to learn anything, and you're not going to tackle the big problems. And if you look at just your project, your exercise like this, it's a bit useless. So try to put each micro task that you are doing on your path in a really global scale, okay? That is helpful, and also give you, I mean, for me it's an idea of I'm doing something for somewhere, okay? If you want to, you can find like the contacts over there. If you want to know more, just tell me, okay? Thank you so much.
Thank you, Elena. Thank you, Maria. Est-ce qu'il y a des questions en anglais ou en français avec la traduction simultanée? Pas de questions? Pas de réaction? Non? Ah, Pietro.
Yes, thank you very much for your presentation. And I have a question about the urban legacy. With the very few words or keywords, can you explain me the concept, the meaning of urban legacy in your analysis?
Okay, in general, okay. Mm-hmm. In general, as a concept, imagine that, of course, everything that you inherited from the past in terms of urban form. So, for instance, if you consider in this really big folder, even the negative remains. Negative, I mean polluted soils, factories, places that have no value for someone, for most of the people in economical terms, and maybe they have even negative values. Think about a polluted soil. That's a minus, it's not a plus. If you buy it, you buy a debt. So with legacy is a way to use an inclusive terms that is, of course, including also heritage, so something that you inherited, but we are happy about it. But legacy, in this case, is also including even the things that you don't want anymore, that you just come at. The amiant is a legacy, okay.
D'autres questions? Non. On vous laisse partir manger. On se retrouve à 14h.